Hello everyone, welcome back to the channel. Today we are diving with the topic that is the what is classification matrices and its different types. I'm going to explain you only today the one type, then we will continue in the part 2 the next type of the your classification matrices. First try to understand today the about the confusion matrix, which is the most important, and at a beginner level students get oftenly confused with the confusion matrix actually. So we will start with that one. First let's start with the foundational things which is very important before moving ahead. So look at this. This is the classification problem statement. We have the data set in which you want to predict whether the patient has the disease or not. Okay, based on these two features. So this is the data set I have considered. Now, if you want to predict whether the patient has a disease or not, what you will do? You will fit onto the classification model, right? It can be any model. So let's consider we have applied the logistic regression. Okay, you have applied the logistic regression model. So what will be the output of the model? Let's draw the table here. This is the one. Your actual value is this one. 1, 1, 0, 0, 1. 1 belongs to the patient has a disease, 0 belongs to patient does not have a disease. Okay. And this is the value predicted by your model when you fit it onto the logistic regression. So first is 1. So this means patient has the disease. Your model is also saying yes, he has the disease. So this is correct, right? Again, the patient has the disease. Your model is correct. Correctly predicted it. Yes, has the disease. The next is 0. This means in actual, the patient does not have a disease, but your model is saying no, he has a disease. So this is incorrect. 0, no disease, but model also saying yes, does not have a disease. So this is the correct prediction. Again, 1, patient has a disease, but your model predicted no, he does not have a disease. So this is the incorrect. Now you can see there are some values which is incorrectly predicted. Then can you deploy this kind of the model? No. Before deployment, you need to evaluate it. Okay. For the evaluation, you need to evaluate. What is the meaning of evaluate now? To check whether your model is working correctly or not, or technically, whether how many values your model was able to predict correctly. Okay. So for that, we use classification matrices for classification problems. Okay. Classification matrices. Okay. This is minded. This is only used for classification. This you cannot use it for regression. Okay. So there are a different type of your classification matrices. The first one is your accuracy. The second one is your confusion matrix. You can also pronounce it matrix too. Okay. So this is further divided into two parts actually. We have the problem statement today with the binary output, only two outputs, two classes. Either the patient has the disease or no disease. So two outputs, 0, 1. So that is called binary. But you might have in real time more than two classes to predict. For example, if I'm giving you the pictures of the three flowers, I'm asking you, can you predict whether this is a lotus, rose, or lily flower? So this is a multi-class, okay? The next your confusion, the classification metric is your precision. Very popular, okay? And this next one is recall. And after that, you have TPR. We call it true positive rate, okay? And the next one is your FPR. That is false positive rate. This is used for OCROC actually. Okay. And then you have the F1 score. Very popular. Okay. So we are going to discuss all these one by one in a like the part 1, part 2, part 3 and so on. Okay. So you can understand it at a deeper level in a most simplest way. Okay. So let's start with today. We will discuss today this one, accuracy and binary confusion metric. Okay. We are going to cover up these two today. Okay. Now, first understand what you are going to learn today. This is very important because based on that, your all other matrices are dependent. Okay. So listen it very carefully. Let me draw the here over model output here again. Okay. So let's consider this again. This is your actual and this is your predicted. If you are a beginner, then you can draw the matrix with me. Okay. 1, 1, 0, 0, 1. Okay. So how many total records we have? We have total records 5. Okay. So it is predicted. This is correct. Let me check. Okay. 1, 1, 0, 0. Okay. So this is our model output. So let me draw here confusion matrix. So this is how you'd need to draw one square box, divided it into the 4 square box. Very simple. Okay. And then you can draw the one graph like the your row here too. And one here. Okay. So how this is on the x-axis, just name it actual values. Okay. And this is on the y-axis. This is predicted. This is predicted. And this is actual. Okay. Write it down. How many like the binary output you have in your data set now or model? 1 and 0. You have only two values, right? 1 belongs to has disease and no disease. 0, right? Write it down here too. Okay, because model is also going to predict only two values. Okay. Now, before I fill here the confusion matrix, first the most important and most foundational thing is important to understand what is true positive, true negative, false positive, false negative. Students often get confused at a beginner level in this. That's why your further all dependent accuracy or classification matrices goes wrong. Okay. So listen it very carefully. Once you understood what is true positive, true negative, it's very easy for you to understand rest of the classification matrices. Okay. So now come back here. Look at this. Your actual value is 1. This means patient has the disease. Your model also says yes, he has the disease. So this is correct, right? And in confusion matrix, we call it true positive. Okay. We call it true positive and write it down here. Okay. Now we will check the count of true positive value. How many true positive value you have? 1. This is correct. This is correct, right? Only 2 true positive value you have. Just write it down here 2. That's it. Okay. Now we will move ahead. There are some values which is like actual the patient has the disease, but your model did not predict it correctly. It says no, the patient does not have a disease. What is that case? This one. Okay. So when your actual value is positive and your machine is saying negative, then this is called false positive. False positive. And write it down here. And check the count how many values it is incorrectly predicted. This one, only 1. Okay. So you will write down here count 1. Okay. Now the next is your true negative, right? This is negative value. The patient does not have the disease. right? This is, sorry, true negative. This is actual value. The patient does not have a disease, and your machine is also saying, yes, he does not have a disease. Now check it. This is the one. This is incorrect. We will not count it right now. This is correct, right? Patient does not have a disease in actual. Your machine is also saying, yes, he does not have a disease. This is called true negative. So write it down here. Okay. So how many values it is? Only one, right? Because this is predicting correctly. So this is patient has a disease, but your machine is saying no, he, sorry, machine, in actual the patient does not have a disease, but machine is saying no, he has the disease. So this is wrong. This is called false negative. Now fill it here. False negative. How many cases you have? Only one. Fill it with the 1. Now count it, total cases 2 plus 1, 3, 3 plus 1, 4, 5. Total records are 5. So this will become now your confusion matrix. In actual, you are not going to write it down like this way because your Python method confusion matrix will does this for you. My main goal is to make you understand so you can interpret the results which is developed or done by your Python methods. Once you understood the true positive, false negative, true negative, this means everything is good. Okay. Now you understood about the confusion matrix, how it is like withdrawn, what are true positive, false positive, how your model is going to be, or your confusion matrix method is going to draw it in for your problem statement. Okay. Now we will move ahead with the accuracy now. In this, we can look at it the now records here. If we talk about these records, you have a total records 5. Out of these, 3 records belong to has disease and 2 records belong to no disease. This seems to be the balanced data, right? Now we can calculate the accuracy. First, try to understand. This is accuracy diagonally. Okay. So what is the formula of accuracy? Accuracy means it will check the total correct value predicted by your model. It does not matter either it's a true positive, true negative. It is going to count to total correctly predicted values from your model, by your model. Okay. So the formula is TP plus TN divided by TP plus TN plus FP plus Fn. Okay. Or total number of records. Okay. So how many? 2 plus 1. How many of these are? 5. 3 by 5. 6. This means 60% accuracy. Okay. This is good for this kind of data set. Okay. Let's see. Now we will take second example. You have the total records 10. Okay. This is also divided into 2 classes, 1 and 0. Patient has the disease, does not have the disease. But in this, you have the 9 cases which belongs to this class and 1 case belong to this class. So what is your data is this? This is the imbalanced, right? Because you don't have the enough data belong to this class. So when you fit any model onto this, what will happen in that case? What will happen in that case? Let's say this is the one. Okay. So this is your actual. This is predicted. Okay. So how many values you have? 1, 2, 3, 4, 5. 5, 6, 7, 8, 9. The last one is your this one. Okay. So when you applied any model onto these, either random forest classifier or logistic one, your model predicted like this way: 1, 1, 1, 1, 1, 1, 1, 0, 1, and 1. Something like that. In this case, what will happen? Draw the confusion matrix again here. Let's draw. This is your true positive, true negative, false positive, false negative. How many true positive cases you have? 1, 2, 3, 4, 5, 6, 7, 8. How many false positive? Only 1, right? How many true negative? 0. It was not, there was only one class. The patient does not have a disease, but your patient machine is saying no, he has a disease. So this is going to be false negative. Okay. So now if you apply on these accuracy matrix, apply this 8 plus 0. How many total records? 10. 8 by 10. 0.8. 80% accuracy, right? But this means your model was able to predict correctly only the one class, right? It did not get a chance to learn about it because the data is imbalanced. Tomorrow, if in the test data, let's say you got, if the test data you have 10 records again, right? And in this, your one first belong to 5 records and your 0 belongs to 5 records. It won't be able to work good because it did not get a chance to learn on this. So it might show you on the training again 90% accuracy, which you will be very happy, but it is going to be fail on this. Okay, so this is a problem with the accuracy. This is the disadvantage of the accuracy. So that's why you need to use further the metric that is called precision and recall. Okay, there are a furthermore that is your F1 score. Okay, and TPR, FPR. Okay, so these matrices you will learn in the upcoming video part 2 step by step. Okay, but today my goal was to make you understand what is confusion matrix, what is TP, FP, what is accuracy, and when you should use it, and when you should avoid it, and when you can use the other one. But I will explain now in my upcoming video first this one multi-class, and then we will move ahead with the precision and recall and so on. Okay, so this was the all about over today, the confusion matrix. And I hope it makes sense to you. If you still have a confusion, drop a comment and let me know for which model or problem statement you are going to use it. Thank you so much for watching this video. If you are new to my channel, don't forget to subscribe my channel, hit the like button, hit the bell icon button to watch my more videos so you don't miss any notification. Thank you so much. Happy AI learning.